So section 9.1 is on multiplying and dividing rational expressions. Yeah, if you guys want to turn off the light, you can. One of the lights. Okay, so we're going to start out with rational expressions, which are fractions, right? Rational means fractions, that look like 5 over x, x squared minus 9 over x plus 3, and so on. So we simplify rational expressions the same way that we simplify fractions. So if I was going to reduce 15 over 24, I think about the factors that go into both 15 and 24. So 3 goes into both of them. So I think of 15 as being 3 times 5, and 24 as being 3 times 8. And then I reduce out by 3. I divide each, the numerator and the denominator, by 3, and I end up getting 5/8. Okay, so that's what we're going to be doing today. We're going to be thinking about the factor that goes into both of them. We're going to be reducing out by the factor. Okay, one thing to mention is that if we have addition, like if this had been 3 plus 5 over 3 plus 8, you cannot say that it is cancel, cancel 5 over 8. Okay, you are not allowed to do that because this is 8 over 11, right? 3 plus 5 is 8, 3 plus 8, or 3 plus 5 is 8, 3 plus 8 is 11, and 8 over 11 is not equal to 5 over 8. Does this make sense? So the same thing with fractions, with x's. You're not going to be able to like reduce out by x squared there. Do you guys see it? So do not do that. Every single year I say that, and then every single year there's like 5 people that do it on the test. Just like every year with the conic sections, I say don't mix up your h and k because you'll mess up your vertex, your foci, and so on. And then every single year people do it. Okay, it's sad. I'm a broken record, I promise. Okay, so anyway, so 10x the 8th over 6x the 4th. Okay, so we did ones like this in chapter 5. What I'm doing is I'm thinking about 10 over 6. I'm thinking of it being 2 times 5 over 2 times 3. So I'm reducing. So the 10 and the 6 reduce down to 5 over 3. And then remember the x the 8th and the x the 4th. If I have 8 x's on top and 4 on the bottom, they reduce out and I'm left with x the 4th. So my answer is 5x the 4th over 3. Okay, do you guys remember how to do those ones? All right, so those are the monomial ones. All right, so these ones are a little bit harder. Like I said, you can't just reduce out by x squared. A lot of people try that every single year. Don't do that. We have to factor. We factor the top and we factor the bottom. So I'm going to need an x and an x. I need my last numbers to multiply to be -2, so I need a 2 and a 1. And I need for my outer and inner terms to combine to be positive x. So in order for that to happen, I need a +2 and a -1. On the bottom, I need my x and my x to make x squared. I need my last numbers to multiply to be -3, so I need a 3 and a 1, and they need to be opposite each other. Like one is positive, one is negative. My outer and inner need to combine to be +2, so I need a +3 and a -1. So when I do that, I notice that I have x minus 1 in common on the top and the bottom, so I can reduce out by it. So my final answer is x plus 2 over x plus 3. Okay, it can't go down any further because I can't like break it apart into multiplication. Don't cancel the x's and say it's 2/3. Every single year people that do that. They get all the way to the end and they mess it up. Okay, so this next one I have 4x minus x squared all over x squared minus 2x minus 8. Okay, so I'm going to pull out, there's a GCF on the top. Right, so I'm going to pull out the GCF, which is x. So I'm going to have x times 4 minus x all over, and then I'm going to factor the denominator. So I'm going to have x and x, 4 and 2. So I need a -4 and a +2. That way my outer and inner combine to be -2. Now these two factors right here are almost able to be canceled. You see how they're almost the same thing? Okay, but they're not quite. What's wrong with it? Yeah, one of them's like 4 minus x, one of them's x minus 4. So we can't reduce out. So what do I need to do? Yeah, Jenny? Yeah, so on the top, what I'm going to do is I'm going to pull out a -1. So I'm going to have times -1 times -4 plus x. Right, and then on the bottom, I'm going to have my x plus 2. And I'm going to have times x minus 4. Now you can kind of see that they're the same thing, right? I have -4 plus x. That's the same as x minus 4. So then it reduces out. So my final answer is -x over x plus 2. Okay, so we're going to shortcut that. You're going to get to the point where you see those right away when they're opposite each other. So if you see that you have like 3 minus x, and then on the bottom you have x minus 3, what I want you guys to do is I want you to cancel, and then put a negative. out front. Does that make sense? So you're going to do it very quickly. Okay, so next up. So what if we have multiplying fractions? So when you guys were in elementary school, you learned how to multiply fractions. You learned that you can multiply across the top, and you can multiply across the bottom. So if you have something like 27 over 16 times 24 over 81, you could multiply 27 times 24, find what that is, and then multiply 16 times 81, find what that is, and then reduce. But it ended up being a lot of work. Once you guys started doing that method, you learned that there was an easier way. What do we do? You can cross-reduce. You can reduce like on the top and the bottom on the other side, right? What else can you do? You could reduce top and bottom on the same side, right? It's basically anything that's on the top will reduce out with anything that's on the bottom. Because what's happening is you were multiplying all the way across the top, multiplying all the way across the bottom. Anything on top that has the same factor as the bottom will reduce. So things like 16 and 24, they're both divisible by 8, so I would get 2 and I would get 3. 27 and 81. Maybe you don't realize that 27 goes evenly into 81 3 times. But you do know that, that 9 goes into them. So we divide by 9. 27 divided by 9 is 3. 81 divided by 9 is 9. And then maybe it gets a little messy, so you need to rewrite. So you have 3 over 2 times 3 over 9. Well, from here, you could multiply across the top and get 9 over 18 and then reduce. Or you can continue doing this process. You could see 3 and 9 reduce out. You get 3 and 1, right? And then 3 and 3 reduce out. 1 and 1. So in the end, you only have 1s on the top. 1 times 1 is 1. 2 times 1 is 2. That's your answer, 1/2. So we use this method that you guys learned a long time ago, and we use it for these rational expressions. Okay, so what we do is we want to try to factor as much as possible on the top and the bottom before we multiply things out, because it's going to be a mess if you multiply it out first. Think about it. Imagine polynomials that are 3 terms multiplied by another polynomial that's 3 terms. Right? We don't like doing that. So if we can reduce, it's going to be much easier. Okay, so this first one is kind of like what we did in chapter 5. So I have 3x to the 5th y cubed over 2x cubed y to the 7th times 10x cubed y to the 4th over 9x squared y to the 5th. Okay, so what I'm going to do is I'm going to reduce out in that fraction, like in the first fraction. So when I see x to the 5th and x cubed, those reduce out, right? It becomes x squared on top. Okay, and then I have y cubed and I have y to the 7th. Well, those reduce out, and I get y to the 4th on the bottom. So just right now, I have 3x squared over 2y to the 4th, just in that first fraction. Okay, then let's reduce out the second fraction. So I have x cubed and I have x squared. Right, those reduce out, and I'm left with an x on top. And then y squared, or y to the 4th and y to the 5th reduce out, and I'm left with a y on the bottom. So I have 10x over 9y. Okay, anything else you see that can reduce? Yeah, the 10 and the 2 reduce to give you 5 and 1. And then the 3 and the 9 reduce and give you a 1 and a 3. Then we're ready to multiply across the top. So I have 5x cubed, right, x squared times x. And I have 3y to the 5th. And that's your answer. Okay, we like those ones? All right, so let's get a little bit harder where we actually have like big, long polynomials that we have to factor. All right, so this first one. So I have x minus 3 over 4x plus 20 times x plus 5 over x squared minus 9. The thing that people always mess up on the test, this is where you guys write down, Mrs. Cox said that they always mess this up. Don't forget this on the test, blah, 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 is this right here, the 4x plus 20. Because people see like it's x to the first, and they think that it doesn't factor any further, right? Like it's not an x squared term, so they're like, oh, we're done. But you guys see it? There's a GCF. The GCF is 4. So we're going to pull out a 4. So I'm going to have x minus 3 over 4 times x plus 5 times x plus 5 over x plus 3 times x minus 3. So I have factored everything. I factored all the numerators, all the denominators, as far as they go. So now I reduce out. So I have an x minus 3, I have an x minus 3. I have an x plus 5, I have an x plus 5. So I have nothing on top times nothing on top. What do I get? It's a 1, right? Not 0, it's 1. So I get 1 on top over 4 times x plus 3. And I just leave it like that. I don't want you guys to necessarily multiply it out unless you were doing like a multiple choice test. And then you had to see if your answer matched another answer. I like this form. I like to see if it goes down any further at the end. And who wants to do all that work? Like, what if you have a really long one? You have to read it out. Uh-huh. You got it? All right, so this next one. This is where people usually freak out on the test and they just start canceling everything. Like, I always have people that are like, oh, x to the fourth, I'm going to cancel both of those. No, you cannot do that. There's like a plus or a minus in between them, so don't do that. Okay, take things one step at a time. Go kind of slowly. Think, what do I have here? So if I have 1 minus x to the fourth, that is the difference of two squares. 1 is 1 times 1. X to the fourth is x squared times x squared. So when I factor, so difference of two squares, I get 1 plus x squared times 1 minus x squared. All right, and then the x to the fourth minus x, well, that has a GCF. So I pull out an x. So I have x cubed minus 1. Then I have times. So I have my x squared all over. Now I have x to the fourth plus 2x squared plus 1. So I'm going to do my two sets of parentheses again because it's a trinomial. And I'm going to do x squared and x squared. Oops. And I need plus 1 and plus 1. So that way my outer and inner combine to be that 2x squared. All right, anything else go down further? How about this 1 minus x squared? It doesn't cancel. Difference two squares, right? Yeah? Exactly, 1 plus x, 1 minus x. So I'm going to have 1 plus x squared times 1 plus x times 1 minus x all over x times, do you guys remember how to do the sum of two cubes and the difference of two cubes? I heard so many groans. Why groans? This is a fun one. This is the SOAP one. Do you guys remember SOAP? So remember, if you need to write this like up here somewhere, a cubed minus b cubed. It factors into a binomial and a trinomial, so a little parenthesis and a big parenthesis. In that first parenthesis, all we do is we drop our cubes. So I have a minus b. In the next parenthesis, I have 3 spots. In the first spot, I square the first item right here. A times a is a squared. In the last spot, I square the second item, so I get b squared. And in the middle, I multiply the two together. A times b gives me ab. And my signs are SOAP, same, opposite, always positive. So if I have the same being a minus, opposite is plus, always positive is plus. So SOAP. So we're going to do that for this one. If I have x cubed minus 1, right? X cubed minus 1 is x cubed minus 1 cubed. So in the binomial, I'm going to just drop my cubes. I'm going to have x minus 1. In the trinomial, I'm going to square the first item, x squared, square the last item, 1. And in the middle, I multiply the two items together. X times 1 is 1x. Same, opposite, always positive. Right. Now I'm ready to cancel. That's the fun part. We like canceling. All right, so we're going to look for anything that's the same on the top and the bottom. So how about 1 plus x squared is the same as x squared plus 1? And then I have x squared here, and I have x on the other one. So I can reduce those out and just have an x, right? It's always hard to cancel x's. I always circle them. It's kind of weird. It's always good to have colored pencils or a marker, or not marker, but a pen that's colored for the section so you can see your canceling and stuff. All right, anything else? We talked about this one. Close, not 1 plus x and 1 minus x though, not those ones. How about this one and this one? They're the opposite each other, right? Of each other. So it's like I pull out a -1 from one of them, and then they would reduce. So what I'm going to do is I'm going to put a -1 out front. Okay, so what I get is -1 times 1 plus x times x. So I'm going to do -x times 1 plus x Oops, or x plus 1, doesn't matter, all over x squared plus x plus 1 times x squared plus 1. And that's as far down as it goes. X squared plus 1 doesn't factor any further. Remember, that's prime. When you have the sum of two sum of two squares, I mean, like x squared plus 9, it's done. All right, so how about division? When we had fractions, when we were in elementary school, and I gave you something like, I didn't give it to you, but when your teacher gave you something like 1/2 divided by 3/4, what did we do? Yeah, we flipped the second one and we multiplied, right? So we did 1/2 times 4/3, and we multiplied across. We're going to do the same thing here. So if I see a fraction divided by another fraction, I'm going to flip the second one, right? Find the reciprocal, and I'm going to multiply. So for this one, I'm going to have 5x to the 4th over 8x squared y squared times 8y to the 5th over 15. And I'm going to start reducing. So like 5 and 15 make 3. 8 and 8 go away. Look at my x's. I have x to the 4th over x squared. Right? So if I had 4 x's on top and 2 on the bottom, I'm going to have x squared on top. And then I have y to the 5th and y squared. So I cancel, I get y cubed. So my final answer is x squared y cubed. And then everything on the bottom's gone except for 3. So x squared y cubed all over 3. See how it can get kind of messy? You got to keep track of all those. All right, so on this next one, I'm going to flip, and as I'm flipping, I'm going to go ahead and try to factor everything as I'm going, okay? So x to the 4th minus 9x squared, that one has a GCF. So I'm going to pull out an x squared. So I'm going to have x squared times x squared minus 9. All over. I'm going to do my two parentheses. I'm going to have x and x. I'm going to need -3 and -1, right? X minus 3 times x minus 1. Okay. Now I'm going to flip the second parenthesis, or the second fraction. I'm going to flip it over. So my x squared minus 16 is now going to go on the top. So I'm going to have x plus 4 times x minus 4. And then on the bottom, I have a GCF again. I have a GCF of x squared. So I'm going to pull out an x squared. So I have x squared plus 2x minus 8. Okay. It's not all the way factored yet. We can still go a little bit further. You can reduce along the way if you want to. Like if you want to get rid of the x squared, you can. Like x squared on top, x squared on bottom. I'll go ahead and leave it so you guys can see it through the notes. Okay, so if I have x squared minus 9, that factors into x plus 3 and x minus 3. And then I have x minus 3 and x minus 1. And then the top is still x plus 4 and x minus 4. But the bottom becomes x minus 2 times x plus 4. Do you guys see how I factor that one? The last numbers need to multiply to be -8, and your outer and inner swoops need to combine to be +2. Now we're ready for the fun part, canceling. X squared goes away, x squared goes away. X plus 4, x plus 4. X minus 3, x minus 3. Anything else? Nope, that's it. So our answer is going to be x plus 3 times x minus 4 all over x minus 1 times x minus 2. And that's it. Some teachers make you multiply out. Some teachers make you like FOIL and get x squared minus x minus 12 over x squared minus 3x plus 2. I don't care. I have you keep it this way just so you can see at the very end, like, oh, I couldn't go down any further. These are my final factors. And really, like, what's the point? But I always do tell my students, if you go too far and you do multiply it out, but then you make a mistake when you FOIL, I count you off the point. So even though you had the right answer right there, if you go too far and messed up, then you miss points. Which is mean, but that's what they do in the AP Calc exam. If you go too far, you lose points. All right, so this next one, same idea. So we have a GCF on top. We also have a GCF on the bottom. Those are the biggest points that people will miss on the test. They forget the GCFs. So I'm going to have 5 times x plus 5 all over 4 times x minus 5. And then I say times, right? So I had divided by a fraction, so I'm going to do times the reciprocal. So I'm going to put a 12x on top. And then on the bottom, I had x squared minus 25, so it's going to be x plus 5 and x minus 5. Lots of canceling. So I'm going to cancel my x plus 5, x plus 5. My 4 and my 12 can reduce out. Right, so when I reduce those, I'm going to get a 3 on top and a 1 on the bottom. But nothing else can cancel. Why can I not cancel the x minus 5s? They're on the same level, right? One's not on top and on bottom. They're on the same level. So my final answer is going to be 5 times 3 times x, so 15x over x minus 5 times itself. So you could write x minus 5 squared, or you could do x minus 5 times x minus 5. Doesn't matter. It's probably the easiest way, right? All right, same one on number 4. So number 4, I have a 7 that I can pull out. So I'm going to have x plus 2 times 7. And then I have x cubed minus 8. So you guys see that's the difference of 2 cubes? It's x cubed minus 2 cubed. Okay, so that means I'm going to do a binomial and a trinomial. In the binomial, I'm going to have x minus 2. I just dropped my cubes. Then I square the first item, x squared. I square the last item, I get 4. I multiply the 2 together to get in the middle. So I have same, opposite, always positive. So you have x minus 2 times x squared plus 2x plus 4. All right, then I do times. I flip that second fraction. I do the reciprocal. So I'm going to have x plus 2, x minus 2 on top. And then on the bottom, I'm going to pull out the negative 2. So I'm going to have x plus 2, like that. And then I reduce out. So x plus 2, x plus 2, x minus 2, x minus 2. So your final answer is 7 times x plus 2 over negative 2 times x squared plus 2x plus 4. And if it really bothers you that there's a negative on the denominator, it is kind of weird to write a negative on the denominator, you can just move it to the top, right? Like you could do plus here on the bottom and then minus. It doesn't matter either way. Right, yes?
Why can't you also, I mean, like, I know that you can't also cross out the other x plus 2, but, like, why can't you do all 3?
Yeah, like I could have done this one and this one. I could have canceled those and then left this one not canceled. But I would have to have an equal number on the top and bottom to get rid of all of them, right? So, like, 1 will cancel on the bottom with the 1 on top.
But if you had, like, 8, then you could cancel all of them if they were in the right spots.
If you had, what do you mean? Like, if I had 4 on top and 4 on the bottom?
Like, if you had all the same number but the same thing, like, you can cancel more than 2 as long as it's an even number.
Right, as long as you have the same number on the top as what's on the bottom, then you can cancel all of them. Yep. Okay, let me answer Allison's question real quick. All right, try the next thing. So look at the crazy fractions within. All right, so it's saying sometimes you've seen, oh, I guess we have not crazy fractions within fractions yet. This is solving equations, right? So it says you can solve rational equations, but make sure you check your solution. Some numbers could have made the original expression undefined, so you could have extraneous solutions in these. Okay, so we're always going to check. And you want to make things as easy as possible. Don't make it harder than what it is, Alex. So like the first one, I have x squared minus 25 over x minus 5. Okay, you want to factor that. You want to factor the top and the bottom. So that you can reduce out the x minus 5 and get a super simple equation, which is just x plus 5 equals 14. You like that. So we get x equals 9. But even though you do that, you always want to check. Okay, so if I check 9, I have 9 squared minus 25 over 9 minus 5. That's 81 minus 25 over 4 which is 56 over 4. That does make 14, so that works. Okay, so 9 is your answer. Yes?
Oh, wait.
Yep. All right, so let's say you go too far. Let's say you do this the long way. So don't write this down in your notes, but pay attention because we're getting ready to do it for number 3. So pay attention to what I'm doing here. So if I have x squared minus 25 over x minus 5, and let's say I don't realize that I can reduce out, that there's an x minus 5 on the top and the bottom, then what I do is I take that x minus 5 and I multiply it over. So I'd have x squared minus 25 equals 14 times x minus 5. So I get 14x minus 70. And since I have x squared and x's, I want to get everything on one side and set it equal to 0, which a lot of you guys forgot on this last test, and it's killing me. So we're going to talk about that problem where you guys did that. Okay, so I'm going to pull over the 14x, so subtract it over, and I'm going to add the 70 over, so I get plus 45. And then I'm going to factor. So I have x minus 9 and x minus 5. I get 2 solutions. I get 9 and I get 5. So this one had one more solution than the shortcut. Okay, we got 5. But if I check that, when I plug it into here, I have 0 over 0 equals 14. Right? So that doesn't work. Sure. Okay. They look very excited. So 0 over 0 equals 14, that's not true. Okay, so we know that we have this extra solution that didn't work. It doesn't work. 9 did work. Okay, so do you see if you go too far, you're going to get an extraneous solution. Okay, so same thing on number 2. So we can factor. Guys, don't look at them. That's not the point of them taking pictures. So when I factor the numerator, I have x plus 5 times x minus 2 equals 7. And on this one, just like number 1, x minus 2's reduce out. So I get x plus 5 equals 7. And you're like, oh, well, that's good. X equals 2. This one doesn't work. So just because we got rid of one of the solutions doesn't mean that this solution is going to actually work. We always have to check on these. Because when I check 2, right, I have 2 squared plus 3 times 2 minus 10. All over 2 minus 2, I'm getting 0 on the denominator. I end up getting 0 over 0 equals 7. 0 over 0 is not 7. So it can't possibly work. So this one is a no solution problem. So no solution. All right, so what if we don't have things that can cancel? Like in this one, we have things that don't reduce out. Okay, so that means that when we can't factor actually, right? X squared minus 2x plus 9, it doesn't factor. So what we have to do is we have to multiply the x plus 5 over. So we're going to have x squared minus 2x plus 9 equals 3 times x plus 5. So I get 3x plus 15 equals x squared minus 2x plus 9. I need to get everything on one side, so I subtract the 3x over. So x squared minus 5x, and then subtract the 15 minus 6 equals 0. And I factor. A lot of you guys get 2 and 3 stuck in your head on this one every single time. You're like, it has to be 2 and 3. It's actually 6 and 1, because they need to be opposite signs and combine to be that negative 5. So I get x equals 6, and I get x equals negative 1. And the nice thing about both of these is both of them do check. Okay, so there's not one that's going to give you a no solution. Okay, does that make sense? How to do the long way? So always CSA factor first, though, because you're saving yourself a ton of work if you do that. All right, so next step. So it says sometimes we've seen crazy fractions within fractions. So these are called complex fractions. It is not because we have complex numbers. You guys remember complex numbers with i's? It's not that reason. It's complex meaning difficult. They look like difficult fractions. So if I have 1/2 divided by 3/5, we don't write it that way. We just make it a simpler form, right? What we do is we do 1/2 divided by 3/5. I always call it the old school division sign, like a little line dot dot that you learned in like 2nd grade. All right, so, and then we flip it. 1/2 times 5/3. So we end up getting 5/6. You guys all know that? We're good. One of my students one time looked up what that was called because I always called it the old school division sign, and he was like, what is that really called? I'm like, I have no idea. He looked it up. It's called an obelus. So if you were wondering, that's what that sign is called. Because we learned what fractions were. So like instead of writing 10 divided by 2, we just wrote 10 over 2, right? Which is 5. So we don't have to do the old school division sign anymore, but we still kind of use it. All right, so this one, so I have 9x squared minus 4 over x minus 2 divided by 3x plus 2 over x squared minus 3x plus 2. So it does look scary. It looks complex, right? That's why these are called complex fractions. So we make it so it doesn't look complex. What we do is we just rewrite. So I do 9x squared minus 4 over x minus 2 divided by 3x plus 2 over x squared minus 3x plus 2. And we flip the second part. So as I go, I'm going to factor. If I have 9x squared minus 4, that is the difference of two squares. So it's 3x plus 2 times 3x minus 2 over x minus 2. And then times, and I flip it. So the bottom now goes to the top. So I have x squared minus 3x plus 2, which factors into x minus 2 and x minus 1. And then the 3x plus 2 is on the bottom. Lots of canceling. 3x plus 2, 3x plus 2. X minus 2, x minus 2. We end up with two things that are on the top, so it's just 3x minus 2 times x minus 1, and we don't write over 1. We just leave it like that. Okay? And remember, I always leave it in the factored form. Don't multiply it out if you don't have to. Okay, so what's different about number 2? Number 2 is even harder. Why is it harder? Yeah, we have a sum of two fractions up here. We need to combine these into one big fraction. So if I have 3 over x plus x over 2, all over x minus 1 over x, and I want to combine those two fractions into one, well, how do I combine fractions? What if I had 1/2 plus 2/3? Yeah, I multiply by 3 over 3 on this one. I multiply by 2 over 2 on this one. I get 3/6 plus 4/6. So I get 7/6, right? I get them so they have the same denominator, common denominators. That's what we're going to do on this. So if I have a denominator of x and a denominator of 2, I need my total denominator to be 2x, right? So I'm going to multiply this first one by 2 over 2. I'm going to multiply the second one by x over x. So I get 6 over 2x plus x squared over 2x, all over x minus 1 over x, which allows me to combine those two numerators, like the two fractions. Okay, don't do 6 plus x squared over 4x. Everybody always tries that. Don't do that. Right, common denominators stay the same, like you're just adding the numerators. 6 plus x squared all over 2x divided by x minus 1 over x, which is 6 plus x squared over 2x times x over x minus 1. It's very sad. There's only one thing that cancels. Don't you guys like canceling? Isn't it fun? I always like drawing lines and things and canceling them out. I feel like it's a to-do list and I'm getting things accomplished. I don't know. No one else feels that way. Okay. So there's only one thing that cancels. What cancels in this case? Yeah, just this x here and this x here. That's all. So sad. It was looking like it was going to be so much better. It just wasn't. All right, so that's our final answer. So 6 plus x squared all over 2 times x minus 1. Okay, so I feel like when I was in high school, I did pretty well on the SAT, like on the math portion. Obviously, I like math, right? But I didn't get a perfect score. And I was always like, I wonder what I missed. I felt really confident about that whole test. Maybe that's really crappy to say, but I felt really good about the whole test, and I didn't get a perfect score. So when I was in college, I was helping people with test prep stuff, and I came across this problem, and I was like, oh, I totally would have missed that in high school. So this is, I think, what I would have missed on the SAT. So it says, Bronwyn drives 50 miles at a rate of 60 miles per hour. On the return trip, she travels at 50 miles per hour. So she's going the same distance. She's just going 50 miles per hour on the way home, and she went 60 miles per hour on the way there. So it says, what is her average speed? And when I was in high school, I totally would have just said, oh, it's the average of the two numbers, 50 plus 60 divided by 2, 55 miles per hour. Is that what most of you guys would do? Yeah, because you're all looking at me like, why isn't it 55 miles per hour? All right, so you actually can't do that on this. The reason is because she spends a little bit longer, like more time, going at a slower speed. She spends more time going at the 50 miles per hour. So it actually adjusts it. It makes it so it's a little bit slower than what you would think. A little bit slower than 55. So it's going to be a little bit less than 55. So here's what we need to do. I know. It's blowing your mind, isn't it? You're like, man. But on the SAT, now that you know that, you can be like, okay, I don't remember what Ms. Cox told me about doing this, but I know that it's not 55. X that out. And then just go with the one that's directly next to it, but a little bit less. All right. So anyway, here's what we need to do. We need to use our favorite formula from middle school. Distance is equal to rate times time. You don't remember that? Oh, man. All right, and what we're trying to find is the average speed, which is a rate. So what we're going to do is distance divided by time is equal to rate. So in order to find the average speed, what I need to do is find the total distance that she traveled and then divide by the total time that it took her. Okay, total distance, no big deal. She went 50 miles there, she went 50 miles back. So she went a total of 100 miles, right? So this is 50 plus 50. But the total time's a little bit trickier. Let's talk about the way home. Okay, on the way home, she went 50 miles per hour. She covered a distance of 50 miles. So if she's going at a rate of 50 miles each hour, and she went a total of 50 miles, how many hours did it take? It took 60 minutes. It took an hour, exactly, right? Now on the way there, she was going faster. Okay, so if she's going faster, it's going to be a little bit less than an hour. It does take her 50 minutes. Good job, Yaya. Look at you. On top of this. Okay, so what I want you to do every single time you do these problems is I want you to write distance equals rate times time, but I want you to talk about T1, and I want you to talk about T2. The first time and the second time. So for time 1, she went a total of 50 miles at a rate of 60 miles per hour. So T1 ends up being 50 out of 60, or 5/6. So 5/6 of an hour. That's why Yaya said 50 minutes. So that's this first one. Now the other one, distance equals rate times time 2, right? Now she goes 50 miles. We don't know her rate, but we knew that we don't know her time. We know her rate was 60, no, I'm totally messing up. Her rate was 50 miles per hour. So her second time we said was an hour. We knew that one right away. So plus 1. Notice how we have a complex fraction. We have 50 plus 50 over 5/6 plus 1. Can we solve it? Sure. So the top becomes 100. The bottom, 5/6 plus 1, is 5/6 plus 6/6, which is 11/6. So I get 100 divided by 11/6, which is 100 times 6 over 11, which becomes 600 over 11. And if you find that on your calculator, it's 54.54 repeating miles per hour. See what I said? A little bit less than what you would think it is. Just a tiny bit less, though. Not much. Okay? So here's the hard one. This is what the SAT likes to do now. Gotta hate this. So they don't give you the distance. So it says Jared averages 3.6 feet per second when walking downhill on a mountain trail and 2.0 feet per second on the return trip when walking uphill. What is his average speed for the entire trip? Rounds to the nearest 10. So notice at no point did I tell you how far he traveled. So that's where people are just like, I have no idea. I don't know. All right, you know that you can't add them together and divide by 2. It doesn't work that way. It ends up being a little bit slower than that. So here's what we do. We let D equal the length of the trail for his distance. And really, you could let it be anything. You could call it a mile, 2 miles, doesn't matter. The number that you put here has no, it doesn't matter at all. It will end up going away, and I'll show you why. Okay, so we set up our average speed, and we know we need the total distance divided by the total time. And in this case, his total distance was d plus d. We don't know what d is. And his total time, remember, that's when we do our d equals r times t1, d equals r times t2. So we have our distance, little d, equals our rate, which was 3.6 times t1. So d over 3.6 is t1. And d equals 2.0 times t2. So d over 2, or 2.0, is equal to t2. So we put those in here for our total time. D over 3.6 plus d over 2. And we solve it out. And it looks complicated, doesn't it? You're like, what are all these d's? Where are they going to go? They're going to go away completely. We won't even need them. So the top becomes 2d. The bottom, we have to get common denominators. Okay, so when I get common denominators, I'm going to multiply the first one by 2 over 2 and the second one by 3.6 over 3.6. So I have 2d plus 3.6d. What do I get? 2d plus 3.6d. 5.6d over 2 times 3.6, which is 7.2. So I get 2d divided by 5.6d over 7.2. See where it goes? 2d times 7.2 over 5.6d. See how the d's completely go away? They're gone. So we get 14.4 over 5.6, which is, someone help me out. Who has their calculator out? What is it? 2 point what? Is it 2.571? That's the number that's in my head from first period, but I don't know. It's been a long day. Help me out. 2.571 feet per second. Okay, and that's the answer. Okay, let me give you your homework before you guys head out.
No, I don't really.